So, okay, Unit 16 Basic Electronics. Now, what they're about is they're a branch of, applied physics. Yeah, they're a branch of studying or something, blah blah blah, in physics, which deals with the control of motion of electrons using different devices. Okay, this is some data I'm giving you. Thermonic emission. Okay, metals. Okay, if it's surface, the process immersion of electrons from hot metal surfaces is called thermonic emission. Okay, uh, I can give you an easy, analogy, and that would be, think of it like electrons are emitted from a heat to a metal surface like that, and like a boiling water, whenever it gets hot enough, it turns into steam and leaves the pot. Similarly, when a metal gets hot enough, its electrons gain energy to boil off the surface. Does that make sense? Now, the thermonic emission is produced by, electrically heating a fine tungent flint, and we have a assigned value typically of the voltage, and the current used for this purpose are 6 volts and 0.3 amp respectively. Okay, now I know you might know this, but there are some factors affecting the rate of it too, and that is the surface area of the metal, okay, temperature of the cathode, and types of metal. Now, when the surface area increases, the thermonic emission increases too, because a larger area allows more electrons to be emitted. And the same goes for temperature, since there are more, electron, the heat increases, so at a quicker rate this would happen. Now, the types of metal is important because different types of metals require different type of energy to release or emit, whatever you want to say. Now, going on to the next thing, we will investigate the properties of the electrons. Hey, remember, just take a look at it, figure 16.1. Okay, do that. Fuck you, man. Are you even listening to me, by the way? Just wanted a friendly reminder, asshole. Okay, so to continue, simply the figure 16.1 is the, I guess, fast continuous thing of electrons going up and down. The goal is to like create a beam. I think you should do a research this on your own, it would be better. Anyways, when an electron beam passes between the two plates, it can be seen that the electrons are deflected towards the positive plates. Okay, the reason for this is, now I'm not sure if you know this, but if you configure 16.2, like I was saying, if you look at it, you can see that it's saying the deflection of cathode rays by the electric field. Okay, just keep this in mind, okay, always. And the reason for this, that the electrons are attracted by the positive charges are the repelled by the negative charges due to the force. Okay, and there's a special formula that you need to remember: F equals Q capital E, where Q is the electron charge and E is the electric field. And due to this, the degree of deflection from their original direction is directly proportional to the strength of the electric field that is applied. Now, on the next thing, let's go. Deflection of electrons by the magnetic field. Okay, now simply going about this, man, this is just too much jitter jatter. I'll just be a bit simple about this. Simply the same thing like I told you in 16.2, but this time you throw a magnet onto it. Okay, and that magnet will force it to change its direction. That's what simply it is, just some random jitter jatter. Okay, anyhow, यार क्या कहूँ क्या कहूँ चलो आई डोंट नो 10 मिनट ब्रेक तो ना लो, मुझे पता है तुम्हारी बेहयाई के बारे में, तो कंटिन्यू करते हैं. ओके, कैथोड रे oscilloscope. Yeah, I most probably am saying it wrong, but there's another short name for it, CRSO. Okay, CRO. Wow, so wow. Okay, anyhow, this is a special type of instrument which is used for, magnitudes of charging electric currents or potentials. And now you need to look at figure 16.4, and if you're not looking at it, then I'll remind you some things so you can get at least a rough idea of how it would be. It looks like a torch, to be really frank. If you remember Dr. Stone, the episode where Dr. Stone made a map, and that's what you were thinking. Yeah, think it like that. But now take this analogy. Those old TVs that have those lines up and down all of a sudden, those things like that, this is what it does. It makes those TV lines ups and downs. Now the ones on the left and the right will always make the line go up and down, and the ones that are up and down will always make it go right, left and right. These things that I just told you, up and down and left and right, these are called deflectors. They're called deflecting system, but they have special names. I guess the vertical ones are called Y's, if I'm correct, and the horizontal ones are called X. Okay, now it's going to tell you some useless things like the components. Like, who's going to read that? Anyways, I am. The electronic gun with the control grid. What the hell is a control grid? Okay, let's just say we know what a control grid is and continue. The reflection plates, a cylinder screen. Mashallah. It's the TV shit I told you about, okay? It's that plastic shit. Okay, anyhow, let me just talk more about this CRO, not CSOR. Wow. Again, I'm saying too much wow, don't you think? Anyhow, well, the things we previously studied, that's what the, I guess, CRO is powered by. Not guessing, I'm just saying it as a fact also. Anyhow, the grid that is connected to the negative potential, the more the negative this potential, the more electrons will be repelled, and that from the grid, and hence fewer electrons if less grid. And the more the electron grid, the better the TV works, I guess, if that's a number thing you want to understand. The number of electrons reaching the screen determines the brightness of the screen. See, the better the TV. Hence, the negative grids can be used as a brightness control. Like, you make the TV better if you turn it, if you have more negative electrons or negative potential, not electrons, I guess. But if you have less negative potential, then the TV is shit, just like you. Look, if you're expecting me to explain to you what deflecting plates are, I'm going to just jump out of the screen and slap you, but I can't do that, so just, I don't know, slap yourself. But don't make it a fetish or some sort. Anyhow, the fluorescent screen. The screen of cathode ray tube consists of a thin layer phosphorus, which is a material that gives light as a result of bombardment by fast movement of electrons. What a hard English word, bombardment. Okay. Well, anyhow, the TV thing I was telling you, the useless screen thing I was telling you about, that's what this is. The screens aren't made of glass anyhow. So let's just simply read the main thing. A tube consists of thin layer of phosphorus. Okay, that's the material. We need to remember this. And it gives light. These are the only two pieces of shits we need to care about. The rest is useless. Now, if you studied computer or you didn't, I really won't blame you. Analog and digital. We need to study those shit again. Okay. I think I found some words that go in my head. The best way is Analog is that, up and down, the crust and the thrust type shit that you were told about when you were young. The water waves or the mountains up and down and up and down, while digital is just like one of those graphs, like those bar graphs that we keep going after for some reason. I hope they're called bar graphs, unless if their names have changed over time. But yeah, the thing is now, so the as I told you, because the analogs are like sea, mountain, or whatever you want to think of it, like this. That's why their values vary constantly. And then there's the opposite, that's called digital. Okay, I feel like I'm bullshitting too much right now, so I'll just say it like it is. Digital is just simply zeros and ones, while analog is the shit I told you 10 times repeatedly already, I feel like. Okay, on to the next thing. Okay, you know what an amplifier is, right? If you don't search the name music amplifier, and you might get something. It's a song of sorts. Okay, anyhow, an amplifier either makes your song really good, or it makes the currents or the signals that are amplified, making them stronger, in other words, without changing much of their shape or anything, I guess. That's not a guess, I guess. Fuck man, I say guess a lot. And yeah, that's what amplifiers are. Okay, and I think I didn't give digital, I didn't talk about it a bit properly, but the digital values very, very discreetly with steps. That's how I can best put it. And there's zeros and ones. That's what they simply are always. Now the branch of electronics which deals with the digital quantities is called digital electronics. And I guess the whole data is provided in binary form, and it is easy for computers to process data and all that shit. Anyhow, I'll just read this. I really won't show any creativity on this one. A continuously varying signal is called analog signal. Okay, we're not talking about analog, we're talking about a continuously varying signal. These three words, signal is the word we're using. That's called an analog signal. Okay, remember that. Now a signal that can only have two discrete values is called a digital signal. Now if you don't get that, that means that if you don't get that, it's okay. For example, a voltage with a square waveform is a digital signal. Now if you don't understand that shit, not to worry, I'll give you another easier home example, I guess. Now I don't know if you heard that mistake, but yeah, that was me, I don't know how many seconds ago. Anyhow, where was I was giving you the example, but I accidentally threw it in the back, and I don't really have an editor and I'm too fucking lazy. Anyhow, a light switch, take that into analogy. Now as you know, in binary, zeros and ones. Zero means off, one means on. You can change it however you want. Just take this example for now. Now as we were told, we can only have two discrete values. These are going to be the only two discrete values. That is a rule of thumb, you can say. Now what that means is that you can have a sequence, for example 1 0 0 1 1, and that would mean on off on off on, like that. Don't take the numbers and don't take my on off face value, but this is what I'm trying to tell you. You can only have these two things going on. Okay, and if you actually bothered to, I guess, who am I even kidding, maybe you have, unlike me. Well, analog to digital converter is called ADC, and digital to analog is called DAC. Now the reason why I'm saying these two things very slowly is because I don't want someone to correct me later on. Now the next thing is logic gates, but I think today for that is enough. You must be thinking, oh great, what's your homework or whatever that thing is called? Well, I would give you a homework, and you know what I'll give you? do the reading, learn the graph, remember the graphs that you have learned, the patterns of the two ones, CRO, if I'm correct, that is how it is, and the 16.1. and if you don't know what that is, it's okay, just do some online research, you'll find the graph anyhow, and I'll tell you more things along the way. So these are just some basic questions I'm asking here and there. This is nothing serious you need to take, okay? You will only be ready when you can answer your own questions and everyone else's questions, when you can give your own answer in your own words. That's the best way I can tell you. The first thing you need to do is you need to learn your own answers. Second thing, you need to write down those answers. And then the third thing is, if possible, have anyone, make them sit with you, your parents, your friends, anyone else, and just teach them what you have learned. That will, I guess, refine your knowledge in a way, even though writing should, but it works. I've seen it, so who am I to judge? Anyhow, just explain to me everything so far that you understood, and if you have any questions, don't bother asking, I would say, but to be really frank, I've seen people have problems and I want to help, so sure, why not? Ask me anything. Okay, so now we're about logic gates. Okay, now simply put, the NOT gate is, if in the NOT gate, if you know the triangle and the circle, then the 0 becomes the 1 and the 1 becomes the 0, opposite. Okay, then AND gate. Now A 0 0 1 1, B 0 1 0 1. Okay, now simply, since we know this much, 0 0 is 0, we're simply multiplying the AND gate, so everything is going to be 0 except for the 1 and 1. Okay, then in the OR gate, we're simply adding, so that's why we will have 0 0 will be 0 and the rest will be 1. Now NAND gate. Okay, in NAND gate you have the combination of NOT and AND gate. Okay, so first you make the same thing, you multiply and you get all the zeros in 1. After that you write the opposite because of the NOT. The last thing, the second one, is the NOR gate or the NOT OR gate. Okay, now it's the same thing, but this time because it was plus, all the opposite the same thing. The real thing we need to understand is the XOR gate. It's 0 0 equals 0, 0 1 equals 1, and 1 0 equals 1, and 1 1 equals 0.